Hi and welcome to video 2 of 4 for section 1.6. In this section, we're going to look at limits at infinity. So in the first video, we had x was approaching some number, and as we approached that number, the value of the function either became really, really large or really, really small. A large negative number, I guess. A large positive number or a large negative number, better way of saying it. In this video, we're going to look at what happens as x goes to positive infinity, or what happens if x goes to negative infinity. What value does the function approach at that point? So for example here, let's let f of x be the function x squared minus 1 over x squared plus 1. So if you were given this function and it said, are there any vertical asymptotes? Well, we know there aren't. Why? Because the denominator is never going to become 0. So if the denominator never becomes 0, we don't have a vertical asymptote. If we were to graph this, when x is 0, we have negative 1 over positive 1, which is negative 1. So that's as low as this thing gets, negative 1. It crosses the x-axis at plus and minus 1, so almost like a parabola. But as x gets really, really big, so positive infinity, this thing will start to flatten off. And similarly, as x gets to be a really big negative number, well, it's getting squared, so that's what? That's turning it into a positive number. But they essentially cancel each other out. And so we get that at positive 1, this function, as x goes to plus infinity, or as x goes to minus infinity, gives us 1. So we would write this as the limit as x approaches infinity, positive infinity in this case, of the function x squared minus 1 over x squared plus 1 is equal to 1. So as the function gets close to infinity, we get closer and closer to some number, in this case, positive 1. Couple more definitions for you guys. Again, with this idea of limits at infinity. So, definition 3 for this section, 1.6, says let f be defined on the interval a to infinity, positive infinity in this case, then the limit as x approaches infinity of f of x equals some value L means that f of x can be made close to L by taking significantly large values of x. So kind of like that example I just showed you. As x gets significantly large, i.e. goes to infinity, this function gets close to this value L, in that case 1. Definition 4 says that the line y equals L is called a horizontal asymptote. Of the curve y equals f of x if either the limit of f of x as x goes to positive infinity is equal to L, or the limit as x goes to negative infinity of this function is equal to that same value L. So again, that sort of example I showed you to start, no matter which way we went, it got closer and closer to positive 1. Therefore, the line y equals 1 would be called a horizontal asymptote. All right, let's look at another example. So we want to find, first off, the limit as x goes to positive infinity of 1 over x, and the limit as x goes to negative infinity of 1 over x. So, I forget what section it was now, but I gave you guys the essential functions, and hopefully you wrote those down, sort of committed them to memory a little bit, or at least have your cheat sheet available. If you can graph the functions, it makes figuring out these limits a whole lot easier, because you can actually just look at the graph. Well, I'm going to positive infinity or I'm going to negative infinity. 1 over x looks like what? 1 over x looks like that, right? So for number 1, the limit as x goes to positive infinity, so as I choose bigger and bigger numbers, I get closer and closer to what value? I get closer to 0. So the limit as x goes to positive infinity of 1 over x is 0. Never hits 0, but it gets so close that we basically say it's 0. And 2, as x goes to negative infinity. So now I'm going way off to the left, and which value am I getting closer and closer to? Well, again, the limit as x goes to negative infinity of 1 over x is also 0. So, because the limit as I go to positive infinity and the limit as I go to negative infinity are both 0, that means what? That means that y equals 0 is a horizontal asymptote of the function y equals 1 over x. So quick question, does this one have a vertical asymptote? It does, right? Where is the denominator equal to 0? Well, it's when x is 0. So that means from this part here, I have a horizontal asymptote at y equals 0, but I also have a vertical asymptote at x equals 0. So this one has both. It has a horizontal and it has a vertical. They both happen to be the axes here on our graph. So last little note here for this video. I have the following. If n is a positive integer, then the limit as x approaches infinity of 1 over x to the n power. So whether it's 1 over x to the squared, x to the third, x to the fourth, x to the fifth, doesn't matter. If n is a positive integer, this limit, or if n is 1, like we just saw, is equal to 0. And similarly, the limit as x approaches negative infinity, 1 over x to the n is also 0. All it's going to do is make these curves get bigger or smaller a lot faster, but they still have their limits going to 0. All right, as I said, that was the end of video 2. Come on back and we'll look at video 3, a few examples of now applying these things that we just looked at.